Okay, today we're going to talk about continuous versus discrete. Continuous graphs, you don't lift your pencil. So if you have a graph like this and you can trace the whole graph without lifting your pencil, that is continuous. Discrete, you have to lift your pencil. If you are lifting your pencil, it's discrete. Hint, discrete is much more dots, a little darker as you can see. Continuous is more lines, but not necessarily straight lines, but you can do it without lifting your pencil. Okay, when it comes to story problems, continuous is things that you can have fractions or partial amounts. So if you go to the store, you can't buy like a third a gallon of milk. You have to buy a whole gallon of milk or a half gallon. You can't buy any amount of milk. But if you picture like going where like the bulk bins are and you're buying like scoops of things, that would be more discrete because you could buy and say, I just need a couple of walnuts at the store, and you go to like where the bins are at Smith's or Winco or stores that have the bins, and you scoop out a couple of them and you can get it discrete. I just need a little bit of the seasoning or whatever. Okay, so if you can buy it by the pound, if you're buying by the pound or by weight, it is almost always discrete. If you're buying it by the amount, like one package of gum, 2 packages of gum, whatever, that is continuous. Continuous, you're buying by the amount. Discrete, you're buying by the pound. Okay, the next thing we're going to talk about is mapping graphs and tables. So if you have the numbers 3, 5, 2, -1, 7, 4, and 3, 8. A mapping, you have the ovals, and you're like, okay, here's 3, here's 5, arrow. Here's 2, here's -1, arrow. Actually, here's 7, here's 4, arrow, and here's 3, here's 8, arrow. Now in a perfect world, I should have put the 2 on top and the 3 on the bottom, because technically it should go small to big, small to big. Okay? For X and Y on the table, order doesn't matter on the tables. We will go and put them in order though. 2, -1, 3, 5, 3, 8, 7, 4. You just list them, X, Y. For the graph, you go over 3, up 5, over 2, down 1, over 7, up 4, over 3, 6, 7, 8, up 8. And that is the graph. Domain is your X's. So what are your X's? Well, I've got a 2, a 3, and a 7. There is another 3 there, but I only list it once. I do not repeat my X's. For my range, I list the Y's. 5, -1, 4, and 8. And there are no repeats there, so I don't have to worry about that. Make sure you do not do repeats when you are doing this. All right, the last thing from this unit was if you have like a story problem. So a story problem would be, I make $10 an hour and a $500 bonus after 3 months. So then, to graph that, I'm going to start at 500, and then I'm going up $10 every hour. 520, first 2 hours, so there's my graph. Okay, the y-intercept is 500. That's kind of where I'm starting at, whatever. The rate of change is how much an hour, per week, per each. Look for each of that per in that. So my rate of change is the $10. My equation, y equals 10x plus 500. My domain, I'm looking down here at my x values. Well, I can work anywhere from 0 hours to a lot of hours. Now I realize you actually can't work infinity hours, but if there's no top limit, we say infinity. The range, well, I'm starting at 500, and then it goes up from there. And again, you're probably not going to make an infinite amount of money, but if there's no, you max out, or this is the max you can make, then you just say infinite. Okay? X-intercepts and Y-intercepts. If you are looking at a graph, The x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. And a simple way to do this is just to graph it and look for where they cross. So here, the y-intercept would be 0 and 3. The x-intercept would be 4 and 0. Didn't draw that very well, but pretend like it's a little bit shorter than it is. And I usually will graph them. If you're at home, just draw a quick sketch of a graph paper. You can also always pull up Desmos and graph it there. The thing I want to talk about is end behaviors. End behaviors. You're looking at what is happening and where it is going. So at end behavior, if we have a nice line, there's my line, there's my x-intercept and y-intercept, and I'm going to say as x approaches negative infinity. If we go this direction, we're going up forever and ever and ever. So as x approaches negative infinity, y approaches positive infinity. That is my end behavior. Well, what about if we go the other direction? As x approaches infinity, here we go on this line, go in this direction, y is going down. So y is going to negative infinity, which means my domain, smallest x value, negative infinity, smallest y value, biggest x value is infinity. My range, smallest y value, negative infinity. My biggest y value is infinity. And that's my domain and range. Okay, another example. We have something like, this is 7. Okay, something like this. So as x goes to negative infinity, as we go this way, we're going continuously down. So that's going to be y is going to negative infinity. As x goes to positive infinity, as we go this way, we're stopping at 7. We're not going above 7. That's that line capped at. So then my domain is my x values, negative infinity to infinity. My range is negative infinity. It's domain. My range is negative infinity to 7. Okay, so that is end behaviors. Good luck.